Assalamu alaikum. For the last couple of lectures, we have been talking about software configuration management. In the first lecture, we talked about introduction, the basic terms, and the foundation of what software configuration management is all about. And in the last lecture, that is the previous lecture, we talked about detailed aspects of SCM functions. We talked about identification, we talked about version control, we talked about change control, we talked about configuration audit, and we also talked about status accounting and reporting. And after having a good grounding, fundamental discussion on these functions, we talked about change control process. You know that change control process is a very formal and elaborate process, especially for those work products which have been released, but even for those which have been baselined but not yet released to the customer. The change control process for those work products which have not been baselined is fairly informal, and not a lot of approvals are required to make necessary changes. In the first lecture on software configuration management, we talked about the fact that SCM provides a cover against lack of visibility and lack of traceability. What we will do today is we will continue our discussion on importance and different aspects of software configuration management, and we will start this lecture, we'll start the discussion today on how SCM infuses visibility and traceability through its main functions. So we will begin the visibility aspect first, and then we'll take up the traceability aspect. We had said that SCM has 5 main functions. But if you pay deep attention and care to it, we can actually merge version control and change control under one broader context of control. And so in today's discussion, we will have control instead of version control and change control. And let's discuss how visibility is infused by SCM functions, and we'll start with identification. You see, we need SCM for software products, obviously. For every software project or product, there are developers and there are consumers or buyers and sellers. So with the help of unique identification of every configuration item in the software project, the buyer as well as the seller, that is software customer as well as the software developer, can see what is being built, what is being modified. And so the visibility of each item is improved, is actually known to all concerned parties. So the first SCM function actually removes one of those problems that typically, if SCM is not applied, we fear the lack of visibility in different aspects of a software project. With the same token, that is, if we perform accurate and useful identification of each work product, the management would be able to see what is embodied in the product. So every product or every version of a product consists of several individual large number of configuration items. And so the management would be able to see what is contained or what is embodied in a product. So the visibility improves further. And then all project participants can communicate with common frame of reference. And so everyone who wants to talk about an individual software configuration item can do so with the help of a unique ID. And even that ID includes the version number. So you can see that the visibility is improved substantially from a component which is not known, not numbered, to a level where anyone who wishes to look at, to communicate about it with other participants can do so with the same frame of reference. And so communication between or among project participants become very easy. The second major SCM function is control, which consists of both version control as well as change control. This function also improves visibility. Current and planned configuration is generally known to all important personnel in the project. And it can be known, that is, it can be found out by everyone involved in the project, even if they do not have direct concern with it. But the visibility is there. They are able to know about a configuration item and know about a new version, or to know about any changes that are being implemented to make a new version of the configuration item. And so visibility is improved by the control functions of the SCM. Management can see the impact of change fairly quickly, because the changes are made by an approval process, and the changes are made known to all the concerned parties. And that is why the visibility of the work product or visibility of the configuration item improves significantly. And management has an option of getting involved with technical details of the project if they feel that it is necessary, because all the changes are being published through the reporting mechanism. Now let's see how auditing improves or infuses visibility. Inconsistencies and discrepancies are manifested by audit. So if there are any problems in the work products, in the configuration items, they are highlighted immediately by the process of configuration auditing. State of product is known to management and product developers with the help of whenever this configuration audit is performed. And so you see that with each step, with each function of the software configuration management processes, the visibility is improving and potential problems are identified early. As early the audit is performed, the problems are identified and they can be corrected, and the process can be improved as early as possible. So it was not just a claim that SCM functions improve visibility, but they actually do, as we are discussing. Let's now talk about accounting and reporting functions improving or infusing visibility. Reports are used to inform the status of the configuration item. And so this reporting mechanism, accounting mechanism, is the foremost responsible for bringing to attention of management the status of each configuration item. When it was created, who created it, when was it updated, when was it modified, where was the change request coming from, who approved it, when was it approved, and all of these things are available through the accounting status reports. And so again here I'm emphasizing that accounting and reporting functions of SCM are improving the visibility of configuration items. Actions and decisions are made explicitly and are made available to the project participants. For example, the project participants can get hold of configuration control board's decisions by looking at their meeting minutes, and a database is being maintained, preferably online database is being maintained of events in the project library, when an item was added to the project, when the changes were made, who authorized the changes, who requested the changes, and whenever and whatever changes are made are documented. And so all of these put together substantially improves the visibility of the configuration items. The next issue is infusion of traceability. So let us now talk about this. If we are talking about SCM identification, it provides pointers to software parts in software products for use in referencing. Identification helps us in providing information regarding traceability from where this component is coming. Identification makes software parts and their relationships more visible, thus facilitating the linking of parts in different representation of the same product. As we have said, that identification includes version number, and so whenever a component, whenever a SCI item or an object or a work project gets a new version, the basic number remains the same and version number is added to it. And so when we have, let's say, requirements document 1.0, requirements document 1.1, requirements document 1.2, and continue on, so we know it is the same, principally the same requirements document, but different versions have been created and they have been identified, and so we can trace using we can perform traceability using this identification. And so the SCM function of identification is helping us in improving the traceability of these configuration items. Then we have control. Control makes baselines or helps makes baselines and changes to them manifest. thus providing the links in traceability chain. Whenever we have version control or change control, and whenever a request comes for a change, that request is approved, first assessed and then approved in the control functions. And we had discussed the change control process in the last lecture. And whatever changes are made in a work product or in a configuration item are saved, are stored in the next version of the same work product or same configuration item. And so the contents in the new work product can be traced to the contents from the previous version. And so we are linking the two documents, linking the two configuration items, and that way we are creating the traceability links. It also provides the forum for avoiding unwanted excursions and maintaining convergence with requirements. So with changes being assessed, we cannot allow those changes that do not reflect, that do not implement software requirements. The requirements that have been agreed upon earlier by the customer as well as the developer. And so any approval that is given to the change requests must be done on merit, on technical merit. And that technical merit links or traces the changes and new approved changes and new configuration items to the requirements. So we see that SCM infuses traceability. Now let's talk about auditing. Auditing checks that parts in one software product are carried through to the subsequent software product. This is the task of auditing. And it checks that parts in software product have roots or antecedents in requirements documentation. And so we are again improving traceability by applying configuration auditing. Then we have accounting and reporting function. This also infuses traceability. It provides history of what happened and when. It provides explicit linkages between change control forms. And so the discussion that we have had up to this point, we see that SCM functions, all of them, participate in infusing visibility and traceability in software projects. And these two things help us in reducing and managing confusion. And if we reduce and actually eliminate confusion to a certain degree, then we can make good decisions for project management, from project management's perspective. Now let us consider, or let us talk about some real-world considerations from SCM's point of view, or for SCM. There are 7 considerations or concerns that we must take care of when we are implementing SCM in our organization. First is management commitment. Then it's SCM staffing. Third is establishment of a configuration control board or configuration control authority. Then we have SCM during acceptance testing cycle. Then we have justification and practicality of auditing, then avoiding the paperwork nightmare, and finally allocating resources among SCM activities. Let's now talk about each one of these considerations. The first is management commitment. Management commitment to establishment of checks and balances is essential for achieving benefits of SCM. As like any other practices, any other activities, whether that's quality assurance, whether that's software inspections, whether that's commitment for resources, planning, we need to get management commitment. We need to address the concerns of the management regarding resources and budgets. But once the management is committed, then and only then the benefits achieved by or benefits promised by software configuration management can be achieved. Here you are looking at a picture showing management commitment for SCM. It is a balancing act. The management commitment is keeping the software project, which has two important tasks. One is product development, and other is SCM, software configuration management. And if you look at the picture carefully, if you want to keep the software project stable and you want to keep the software project on schedule, you need to balance both product development as well as SCM activity. If you tilt in one direction or in one activity's favor, the other activity will fall apart. And as a result, the entire software project will suffer. There will be chaotic situation. Because as you can see, the management, the entire software project is sitting on a triangle, which is the management's commitment, on the tip of the management commitment. And so the software project is carrying two very important activities, product development and SCM, on sides of the rectangular bar that's shown. So this picture conveys a very strong message, a message that we need to balance product development with respect to software configuration management. If we fail to do that, there will be chaos in the project. There will be chaos in the entire organization. The next important consideration is SCM staffing. Staffing is a contentious issue because it directly takes budgets and it takes money to hire good people. Initial staffing by a few experienced people quickly gains the confidence and respect of other project members. If we are establishing a software configuration management program, need to get experienced people, and naturally we have to pay them good. It is important to build the image that the SCM team has the objective of helping other project team members achieve the overall team goals, that they are not a group of obstructionists and criticizers. And the picture that we have just seen under management commitment is also highlighted by this fact, that we need to balance both the development effort as well as the software configuration management effort. An SCM organization requires three kinds of personnel. It requires auditors, it requires configuration control specialists, and it requires status accountants. These positions require hard work, creativity, and dedication. important qualification of these people are the ability to see congruence, that is, similarity between software products, and the ability to perceive what is missing from the software product. With these abilities, the SCM team member can observe how change to the software system is visibly and traceably being controlled. And we had seen earlier in the lecture and discussed the importance of visibility and traceability and how SCM functions provide both of them with in the project, in the software project. Now the question is that should all SCM personnel be skilled programmers and analysts? And the answer to that question is no. These particular skills are not a necessity by any means, although personnel performing software configuration auditing should be technically skilled, because they have to look at the different work products. And if we are talking about, let's say, programs, then they have to look at programs, and they need to be familiar with the languages that are used so that they can see if the changes are highlighted, has proper changes have been properly made, and so forth. And so the auditing staff needs to be comfortable, needs to be familiar with these technical skills. For identification purposes, the SCM staff needs the following skills. And again, here we will talk about the skills of SCM staff with respect to the functions that are performed in SCM, or software configuration management. So the skills required for identification include the ability to see partitions. They must have the ability to see relationships between different work products or configuration items, and some technical ability is desirable. They should have some system engineering orientation or software engineering orientation, and maybe some programming orientation. So if they have taken some programming courses, that would be sufficient. The next SCM function is control. Again, this consists of version control and change control. The SCM staffing skills needed are the ability to evaluate benefits versus costs, so that the comparisons can be made as to what the benefits are of the changes as compared to what the costs are. They should have a system viewpoint, that is a balance of technical and managerial viewpoints. They should also have or be able to understand the viewpoint of a user of the system, understand the viewpoint of the buyer of the system, that is the customer, and understand the viewpoint of the seller, that is the developer, that is the organization which is developing software or selling software. And thirdly, they should have an appreciation of what is involved in engineering a software change. Software change is not an easy task, because of the design aspects, because of the characteristics of software design that we have discussed earlier in this course. All the components, all the configuration items in software are linked to each other. They link with each other, they communicate with each other, they send messages to each other, they receive messages from other components, and thus they form a software product. Similarly, components in a software product communicate with other systems, they interoperate with other systems, they communicate with outside world, they communicate with different databases, they communicate with people, and so even a single change request can have far-reaching implications. And so anyone who is interested in performing control-related jobs at the SCM should have or develop an appreciation of what is involved in engineering a software change. Let us now talk about the skills required for auditing. It's very interesting because you require extreme attention to detail. It requires the ability to see congruence or similarities. You need the ability to perceive what is missing. And you also need to have extensive experience with technical aspects of system engineering and or software engineering. And so this is an area where the technical skills as far as system engineering and or software engineering are required. But you also need to have the a very desirable aspect of extreme attention to detail. Then we look at the final set of skills, and that is for status accounting and reporting. It is a tedious job, so you need to have the ability to take notes and record data. So you see that each function, each SCM function has or requires a different set of staffing skills. So now we're talking about status accounting and reporting, and the first characteristic that I mentioned to you was ability to take notes and record data. Another important characteristic is the ability to organize data. It is interesting to note as a side comment that many programmers do not have this ability. They can write good programs, they can think in an organized fashion, but they do not have the skills to organize things, organize data, organize physical things. But this job requires that. And also for status accounting and reporting, some technical familiarity is desirable but is not required. And the technical familiarity could be in system engineering orientation or programming. And so now let's spend a minute or two talking about these staffing skills. It is interesting that each function has and requires a different set of skills based on the tasks that will be performed in these SCM functions. So you can imagine, you can understand that SCM is not just another thing to do in the project. It requires a skilled professional with the characteristics that we have just discussed. Let us now move on to another consideration in the SCM, and that is establishment of a CCB. We had had some discussion on this in the last lecture, but we need to have more discussion on this. As a starting point in instituting software configuration management program in an organization, periodic CCB meetings provide a change control, visibility, and traceability aspects within the project. The CCB meeting is a mechanism for controlling change during the development as well as in the maintenance activities of the software product. CCB membership should be drawn from all organizations within the project. And we had talked about this, and there is no need to repeat all the groups that can have representation in the CCB board. However, whenever a CCB is established or a configuration control board is established, we need to agree on few things. We need to agree on how the decision will be made. So we need to know or develop a decision mechanisms for approving or rejecting a request. Yes, we have talked about the technical criteria. Yes, we have talked about the fact that the CCB should look beyond the current SCI and look at the hardware and the performance and the reliability and the quality issues. But what is the mechanism of reaching a decision? One simple mechanism could be that all board members have a single vote. Another mechanism could be that the chairman of the board would decide after discussion. Another mechanism could be an informal consensus without voting. But the drawback in that case would be that a decision may prolong and a consensus may not reach for a long time. And another corollary that can be attached to it, that if we have an informal decision or consensus mechanism for reaching a decision, and we don't reach a decision within a certain amount of time, then the decision would be made by the chair of the CCB. I've mentioned the fact that the CCB has a chair without actually formally mentioning that a CCB chairman or a chairperson has to be appointed. And there are a number of options. If a customer representative is sitting on the board, then he or she can be a good choice to chair the configuration control board. And there are other options also. So depending on the project, depending on the organization's policies, and a number of other factors, a CCB chair has to be appointed who's going to chair the meetings. And after every meeting, the control board, change control board, issues the meeting minutes, which are sent to all participants and also recorded in the database. These minutes should have a format, and any format can be selected by a project, by an organization. When changes are necessary, a CCB meets to evaluate and manage the impact of the change on the software development process. This is a requirement for a change. The impact of change can be countered in only three ways. Number one, you can add more people to the project to reduce the impact of change. You can extend the time of completion, and you can eliminate other non-essential or less essential functionality or functions in the project. There are pros and cons of each of these options. There are pros and cons of each of these choices that I've described before you. But the CCB and the project management should, especially the project management, should consider the appropriate choice, make an appropriate selection from the three that I've talked about. If a small amount of code is changed, it is redesigned into the old code. If the large amount is changed, a complete subsystem may have to be redesigned as though it were a new product. This happens in those scenarios if there are errors which are forcing us to make changes. And so these modules or these components or these configuration items can be declared as error prone, that lot of changes are being made because errors are being traced to these configuration components. And from a maintenance point of view, IBM rule of thumb that if 20% of the code must be modified, then the module should be redesigned and rewritten. And so this is just a rule of thumb. This is not a rule. This is not a universal rule. This is not a accepted industry-wide practice, but this is one rule of thumb that has been reported to be as practiced in IBM. Let us now move on to the next consideration, and that is SCM during acceptance testing cycle. Often SCM activities are ignored in the testing and acceptance testing cycle, but they must not be. SCM integrated within the acceptance testing cycle maintains a visible and traceable product ready for delivery to the customer. So SCM activities in the testing play a very important role. And now we will discuss the role of each of these SCM functions in testing. So let's take identification first. Identification helps in preparation of release notes, that is the lists of changed software. Identification of development baseline is done in testing. Identification of incident reports is done in testing. And similarly, identification of operational baseline is necessary for software testing. The control function also has an important role in testing. As you know that control activities are managed by and approved by the change control board meetings, in change control board meetings. So these meetings help us in the establishment of development baseline, assignment of testing and incident resolution priorities, and these priorities are agreed on at the CCB level. Establishment of turnover dates, approval of audit and test reports, and approval of incident report resolution. That is, wherever there are reports for failures, and these incidents are then sent to the programming side for detection and removal of defects. And also the establishment of operational baseline. All these decisions are done by CCB, by Configuration Control Board in their meetings. So configuration control board plays an active role even in the testing cycle. Let us now talk about auditing. Comparison of new baseline to previous baseline is an important activity for testing. Assurance that standards have been met are done through auditing, and that will convince the customer about the procedural aspects of development of software. And then actually the act of testing software system is also a form of auditing. And then we have accounting and reporting function. With respect to testing, the logging and tracking of incident reports is done in this activity, in this function, and the publication of configuration control board minutes is also part of the accounting, status accounting and reporting with respect to software acceptance testing. So you see that every function of the SCM, software configuration management, plays an important role in the acceptance testing cycle. The next consideration is justification and practicality of auditing. You see, auditing is a very cumbersome, difficult task, and it consumes a greater part of the SCM budget. But auditing has the potential of preventing the waste of much greater resources. So if we perform auditing, we can save a lot of resources, although this activity itself is quite time consuming and resources are needed in order to perform auditing. Then we have avoiding the paperwork nightmare. It is true that we are generating a lot of paperwork. We are generating change requests, we are generating change report, we are generating engineering change order, we are generating CCB minutes, and so there are a lot of documents that are generated as part of software configuration management functions. But this paperwork does not have to be in paper form. They can be produced in the form of electronic files. They can be placed on internal web servers for viewing, and so unnecessary waste of resources can be avoided. And also, both user or the buyer and the seller should agree on the needed documents to achieve a mutually desirable level of visibility and traceability. These are our two important goals that we should make we should improve the visibility and traceability of software components, of software configuration items in the project. And so it is not necessary that every document that is produced on paper. They can be electronic files, they can be shared by email, they can be put on the internal web servers. So this can be managed. The next is allocating resources among SCM activities. Cost versus benefits must be evaluated for each individual project in determining the allocation of limited SCM resources. Of course, every project cannot afford to fully allocate all resources, and so it is again management's responsibility to develop and devise a plan to allocate resources according to the needs of the project. Let me end this lecture with a very important but little bit related issue of SCM, important but not directly related to the discussion we have had today. In order for us to have a working and organized software configuration management in place, and to benefit from the resources and to utilize the resources we have, we need to address some issues. Number one, how long can we support a particular version of software? That is a management's decision. Another issue is what upgrade paths should be allowed. And third is how many variations and not versions of the product should be produced and supported. And these issues and these questions will help us in determining the scope and manageability of software configuration process that we are implementing in our organization. So, although these are not directly related to the discussion that we have had today, but in order for us, since we were talking about practical aspects and real-world considerations, it is important to keep these three issues in our minds also, in our discussion also. Today we had a good discussion on practical issues and real-world considerations relating to software configuration management. In the next lecture, we will take up another aspect of software configuration management. So I take leave of you until then.